Hi everyone, welcome to today's presentation for the Australasian Collective Road Safety on Road Corridor Safety Assessments using AiRAP, AiRAP and Imagery. My name is Brett Williams. I'm Senior Traffic and Transport Coordinator at the City of Onkaparinga. I've been asked by Jamie to step in to chair today's meeting as he's interstate, and I facilitated, I suppose, the arranging this webinar coming together, or seminar and webinar. So firstly, I would like to acknowledge the land that we meet on today is the traditional lands. Sorry, there is no sound. That's not good. Okay. All right. Okay, you can hear fine. All right. Well, thanks, Michael. I'll keep on going, but yeah, feel free to drop something in the chat if you're not able to hear. Okay, so acknowledging that the lands that in the meeting room here today we meet on are the traditional lands for the Kaurna people, and that we respect their spiritual relationship with their country. We also acknowledge the Kaurna people as the custodians of the Adelaide region, and that their cultural and heritage beliefs are still as important to the living Kaurna people today. We also pay respects to the traditional owners of the land from other areas of Australia where online participants may be attending, and if we have any friends from New Zealand who are also attending, would also like to acknowledge the Treaty of Waitangi and the Māori as the original people of New Zealand. So for people attending here today, if you're not already aware, toilets are through that door out the back there. If there's an evacuation alarm, I'm sure there's some DIT staff here who can basically guide us to what we need to do. And also be aware that today's session is being recorded and will be available later. And for you online participants, you are welcome to ask questions. You might need to just do that in the chat, and we'll keep an eye on that and see if we have any opportunity to have those answers as we go through. We'll just move to the next slide. Okay, so just some updates for the college, for those who are members. So voting for the election of members to the ACRS Executive Council are now open, and you should have received an email with details on that. So I encourage everyone to vote. Leading on from that, the college annual general meeting will be held on the 25th of May, where the outcome of the voting will be confirmed. It's also a reminder that the Road Safety Week starts this coming weekend on Sunday, so quite important for the college. And finally, the annual Australasian Road Safety Conference this year will be held in Cairns, with registrations now open. It will again be a hybrid conference, so please consider taking part virtually if you can't make it there in person. So I'd like to pass over to the first speaker, Matt from RAA, and we'll just get your presentation up. So Matt's going to set the scene for basically the star rating process that the RAA have been doing in SA, and then we'll be moving on to Tony and Peter from Anditi, who are going to explain what they're doing using AiRAP, which is all quite exciting. So we'll move on to Matthew's presentation. All right, thanks, Matt.
Thank you. Thanks, Brett. Good afternoon, everyone. I'm Matt Virtudes, Senior Traffic Engineer here at RAA. And today I'll give you a brief rundown, sorry, I'm not staying in front of the screen, of AusRAP star ratings and just some of the basics for those that aren't as familiar with them or would like to learn a little bit more, leading into the presentation from Anditi. I'd also just like to acknowledge the Kaurna people today, the traditional custodians of the land in which we're meeting, and pay my respects to the elders past, present and emerging as well. So first off, can I just have a quick show of hands for anyone who has used AusRAP star ratings in the past? I expect about 50-50, give or take. So AusRAP, or IRAP, I should say, is an umbrella organisation for road assessment programs across the globe. So EuroRAP, US RAP, China RAP, and over 30 countries use this similar sort of methodology to produce star ratings of their road network. So it began with the motoring clubs across several countries, including Australia, where they would rate roads for road safety advocacy purposes and communicating to their membership base, but it quickly developed into a tool that would be highly useful to road authorities and designers. So an AusRAP star rating is a rating of a road between 1 and 5 stars, where the maximum rating a road can achieve is 5 stars, and the lowest is 1. The way it works is by splitting the road into 100-metre segments and providing a discrete rating for each segment, which then can be smoothed out across the corridor. each 100-metre segment has 78 attributes, of which about 50 are related to the specific road environment. So star ratings are typically reported for vehicle occupants on regional roads, but they also there's also capability to produce a star rating for vulnerable road users in cyclists, motorcyclists and pedestrians on roads where they are present. So it's not just a vehicle occupant rating, but that is the one that's most commonly used in Australia. But countries where motorcyclists are the predominant form of transport, that's a more useful tool there. So it can also be very useful for measuring the success of road upgrades before and after to see, I guess, a measurable improvement on the level of safety. So also the star ratings are a key measure in the current national and state road safety strategies, where 80% of travel, well, the target is to have 80% of travel on high-speed regional roads 3 stars or better. This is something that REA welcomes. It's something we've been calling for quite a few years, and it's a good way to measure the level of success and the level of improvement being made on our roads, and how that progresses over time. Oh, this mouse is sensitive. Okay, so sorry, one last thing. So it can be used at a strategic level or a project level. So I'll give a few examples of that over the slides here, and on to my next slide. So an example, in 2013, the Australian Automobile Association, which is the national body representing the state mobility clubs, worked to star rate the national highway network. So in South Australia, this identified almost 40% of the national network in 2013 was rated 1 or 2 stars, and tried to identify an investment to increase that star rating. So what that worked out to be was $187 million investment to increase the share of 3-star national highway network to 77% roughly. What that would have ultimately resulted in, using a safer road investment plan, which is, I guess, the next stage of the star rating, which brings in the costs of upgrades and uses the inputs to, I guess, deliver upgrades as based on something that's economically sound. It would have saved 1,900 fatalities or serious injuries on the national highway network over 20 years. So what you can see here is a CSV file showing 5 kilometres of raw coding data. This is R.M. Williams Way in the state's mid-north. So this represents about close to 4,000 individual pieces of data that until fairly recently would be manually coded. So you'd be looking at a video footage of the road that's geocoded and putting in your different star rating scores for each of the 78 attributes. You've got your coordinates and so on, and the type of roadside hazard that's present. So it's a very laborious task, and the technological advancements that are happening these days, like the work that Anditi is doing, is taking a lot of the manual and error-prone analysis out of things, and being able to generate these files using a much more intelligent system, and much less prone to human error. So just as an example of some of the attributes to get a bit of an idea, I won't go through the full list. I'll discuss them a little bit more over the presentation, but things like the roadside hazards, the speed limit, the curvature and the geometry of the road are all really important factors that go into producing a star rating. And even, I guess, when we talk about roadside hazards, we look at the distance. Most factors are, I guess, banded into different groups. So for example, a tree on the roadside, we look at 0 to 1 metre, 1 to 5 metre, 5 to 10 metres, or greater than 10 metres from the roadside. So we need to, I guess, not only identify the hazard, but also how much of a hazard, or the location of that hazard in relation to the road itself. So REA uses AusRAP ratings in most of our regional road advocacy. Some recent examples include some highway assessments on Victor Harbour Road and Horrocks Highway. We also use our regional road assessment program, which goes around the state looking region by region, and we try to incorporate cross-sectional star ratings into that to firstly identify the level of safety of the roads, but also then help inform our recommendations that come out of these reports to make sure that, one, they're sound in that they are improving safety, which this is a useful tool to demonstrate that, and also just to check against, I guess, what other interventions could be implemented to deliver a similar level of safety. So it can be really useful to look at, say, for example, the effect of a change in speed limit. So an example here, so this was one of 8 roads a few years ago that were reduced to 100 kilometres an hour from 110. Sure, a few in the room are quite familiar with everything that went on there. So initially, this section of the Goyder Highway up near Clare was a 1-star section. So we're talking about this 100-metre segment pictured. It was a 1-star section of road, 110 kilometres an hour. You've got the curve with the embankment and trees on the outside of the curve. So this was rated 1 star. Following the reduction in speed limit to 100, that actually caused an incremental star rating increase to 2 stars. And what I've shown in brackets is, I guess, the star rating score. So those star ratings, I guess the model gives them a numeric value. So I've got 25.38, which equates to 1 star. So there's different brackets for each star level. Off the top of my head, it's 22.5, it'll go up to 2 stars. 12.5, it'll take it to 3 stars. At 5, it'll take it to 4. And 2.5, it'll take it to 5 stars, being the highest achievable, which is quite difficult on a high-speed regional road in Australia. So after the upgrade here, so we saw pretty much just some widened shoulders and the safety barrier on the outside. So what that then delivered was a 3-star section of road at the 110 kilometre an hour before the speed limit was reinstated. But even reinstating that speed limit to 110 did maintain that 3-star rating, albeit at a slightly lower star rating score. So this is, I guess, showing a really positive improvement to road safety, and something I don't think I mentioned on the first slide, but typically, or the average safety improvement, so each incremental star rating increase is a 40% reduction in the number of fatalities and serious injuries on the road. So 1 to 3 stars is a significant improvement in safety that would be expected on this road. So a few other examples of what 1 star looks like. So quite often we are talking about narrow roads, but sometimes we'll have roads with even sealed shoulders, but exposed roadside hazards or narrow bridges at certain pinch points along the road. So I'll run through a few examples. So this is a section of the Mallee Highway, 110 kilometre an hour speed limit, exposed hazards on the outside of the curve, although the lane geometry is reasonably good. Due to the presence of those trees on both sides of the road in fairly close proximity, this rates 1 star. A very similar section of the Mallee Highway, a few kilometres away from the first one, sees the addition of a barrier and some slightly wider shoulders, which were just over the 1 metre wide, which puts it into the medium bracket in AusRAP, saw it jump up to 2 stars. Another 2-star section here, which I guess initially might look like a pretty good road, and better than a lot of what we do have regionally, but we've got these Stobie poles, and I guess that's the reason I highlighted this one, that those hazards and about 100-metre increments apart, within 5 metres of the road, it's very difficult to get a 3-star road when you have that fixed obstruction there on the roadside. So putting in a barrier to prevent collisions with the Stobie pole, would see that actually rated probably a high 3-star road instead. A 3-star section here, so very similar to the previous. This is part of Victor Harbour Road, but we've got a slightly lower speed limit and a more forgiving roadside environment here. So it's the example I was talking about. A 4-star section, this is a short part of the Riddoch Highway down near Port Macdonald. No roadside hazards on the driver's side, and the Stobie pole protected by a barrier on the passenger side. We've also got some audio tactile line markings, nice smooth surface and really good sight distance. So this one just scrapes in for 4 stars. And 5 stars, very hard to come by. There's not too many examples, but this was a short section of the Wollonga Hill part of Victor Harbour Road, where we've got wire road barriers on both sides of the road, the overtaking lane, and a very wide shoulder to allow for a vehicle to leave the road in the case of an incident or a breakdown. So that's, I guess, an example of the best practice, I guess, in relation to road construction these days, and something that we should definitely be trying to strive for on as many of our high volume regional roads as we can. So how can you begin to use AusRAP star ratings in your own projects? So firstly, you can sign up for a free VIDA account through the iRAP website. I popped to the link here. So that will allow you to get onto the iRAP demonstrator tool, which is a web-based tool to explore the impact of different features of the AusRAP star ratings and how that impacts the rating of a cross section. There's a huge range of iRAP training available through their website. A lot of it is free, and there's some fairly low-cost options as well that do have marked assignments and touch points with someone to actually ask any questions and get feedback on anything on there. And also, I'd always recommend the iRAP coding manual. So when you are coding a project or a cross section or anything, that'll give you a bit more information about each of the individual parameters and, you know, should I rate this tree higher, that's 1 meter from the road, higher than a Stoby pole 6 meters away from the road, and those types of questions. So finally, I'd just like to run through a quick demonstration along Mount Lofty Summit Road, which is just looking at this cross section here in the Adelaide Hills. So this is a narrow, typical Adelaide Hills road, just over 5 meters, seal width, 2.5 meter lanes, and 80 kilometre an hour speed limit. So first we'll log into VIDA and access the demonstrator tool, which I've highlighted here. Next you'll get, I guess, a number of typical cross sections to use. So for this one, I've selected a low standard rural road. This will populate the model with a bunch of default values that you can then go through and tweak, which is what I'll do through this. So these are the default values, trees, both sides of the road, 1 to 5 meters. That's probably the main thing I want to change here. So on the driver's side, we have the Stoby pole, which you can sort of see in the corner here, being the most significant hazard on that side. We've got a pretty steep rocky face on the passenger side there. So we've popped those two as our most significant roadside hazards. We don't have any audio tactile lines or sealed shoulders, so we'll leave those as they are. And what that's done has, by changing those hazards, oh, there's my mouse, can't see that, but up in the top corner, you can see that's reduced the star rating score for both vehicle occupants and motorcyclists. And we don't have a score at the moment for pedestrians and cyclists, and we'll get to that in a moment. Next, we can pop in some mid-block attributes. So most of the defaults in this scenario are fine, but that's where we can put in things like the curvature of the road, the slope, the width of lanes and shoulders and that type of thing. So the only thing I want to change here is the lane width. Make those lanes narrow to represent our measurement on site of 2.5 meters. Once again, that decreases the star rating score. So at a very, very low 1 star at the moment. We can pop in any intersections or property access points within that 100 meter section. We know the next intersection is 150 meters away, so we won't code that into this segment. We'll put that into the next segment as the intersection. So we can leave that as default with nothing. We can look at the traffic flow next. So this is an important factor, and this is what decides whether it generates a star rating for pedestrians or for cyclists. So first off, I want to change the traffic volume to 950 vehicles a day, which is more accurate for this road. And I've added in a cyclist flow as well, because we know this is a popular corridor for cycling and both motorcycling as well. So the most important thing when using the demonstrator here is just to acknowledge the fact that there are cyclists or motorcyclists or pedestrians, which I'll leave off for this example because it's not generally a road for pedestrians. But if we did want to measure that rating, you know, where there's a crossing or footpath facilities and things, we can. But by including the presence of a vulnerable road user, that will then generate the star rating score for them. So once again, by decreasing the traffic volume, we've reduced the risk of head-on and multiple vehicle crashes there. So that's actually increased the star rating score. Next, we can pop in the vulnerable road user facilities. There's nothing. So in this case, we'll leave the defaults for a low standard rural road, which is nothing, but we can put in footpaths and crossings, bike lanes, or even motorcycle lanes if present. And finally, we can add in some information about the speed limits. So the default is 100 kilometers an hour. I'll change that to 80 kilometers an hour, which is the limit for the road, which is obviously generated an increase in the star rating, but the star rating score for each of those 3 users. The thing to note with this, so we've got a speed limit or an operating speed, which is the 85th percentile speed. Generally, we'll use the speed limit unless we've got a good amount of information to say that the operating speed's higher than the speed limit. The model will take into account the highest of these 2 limits. So if you are using this to play around with some star ratings on a local road or a road that you're assessing, you want to be making sure both of those change to the limit. If you mistakenly keep the operating speed at 100 kilometers an hour, that will then take it as the speed limit. Whereas, you know, I think the vast majority of users would be lucky to get to probably 50 on this road. And finally, that gives us our star rating score calculated for each of the road users. From here, we can tweak various inputs and see how that impacts our star rating. So if, for example, we reduce the speed limit to 60 kilometers an hour, we can go back and make that change. And that will actually give us a 2-star rating for vehicle occupants and cyclists, and a much higher star rating score for motorcyclists while still remaining at 1 star. The other alternative would be to maintain 80 and put in some infrastructure improvements instead. So the surface there is pretty poor, so a reseal, some widening, some shoulder sealing, and some better delineation. Once again, achieves a very similar result, 2 stars for cyclists and motor vehicle users, 1 star for motorcyclists. You need to obviously use a little bit of reasoning with this. We can't be putting in 3.5 meter lanes and 2.5 meter sealed shoulders. You know, we've got a pretty constrained environment and obviously limited budgets here. So we've just done marginal widening to get that to the medium width and some narrow sealed shoulders in this case. Alternatively, by incorporating both upgrades, we can also test that, and that's where we get that 3-star level of safety for the 3 road users that we're testing there today. So overall, that's just a really quick summary of AusRAP and the star ratings and how to, you know, how they work a little bit. So hopefully you've all learnt a little bit about that, which will hopefully lead you into the next presentation. But yeah, if anyone has any questions for now, I'm happy to take anything, yeah, in the room. Good. I don't know if there's anything.
Okay, we've got no questions now. We might move to the next presentation. So thanks a lot, Matthew, for that.
Thank you.
That was great. Really good introduction to how this is done. Yeah, and we're up and running. So thanks.
Hello, everybody in here and remotely. So I'm Tony Campbell from Anditi. So we're here today to talk to you about how we've, I guess, approached AusRAP and our sort of technology and the way that the process that we have for looking at the data, for taking data from a range of different sources, from processing that, and then how we come up with the star rating.
Just lost that on the presentation. So who wants talking? I'll do some fiddling. Yeah.
Sorry about that. So we're going to talk about how we apply our sort of technology to AusRAP, and at the end, I'm going to show you how we can sort of maximize the return on investment. So, you know, capturing the data and analyzing the data is obviously a significant cost, but there are lots of other ways in which you can spread that cost out amongst your businesses, amongst your government departments, in order to maximize the sort of the return you can get from that. So we are going to cover that today. So I'm just going to hand over to Peter, and he's going to talk through the process about how we use AiRAP.
All right, thanks, Tony, and welcome everyone. Okay, there's a fair bit in this, so bear with me for the first bit. It'll be a bit dense, and Tony will lighten it up a bit towards the end, so it'll be okay going through it. But basically, we'll talk about what is AiRAP in comparison to iRAP and AusRAP we're talking about, how we go about basically working through that process, what data sources we've got available to us and what we can do with those data sources, checking our input data, which is always a challenge, particularly when you want to go to do things in an automated way because it'll fail if the data's not good in the first place. How we classify and how we classify the LiDAR and put out assets and extraction from it. Some of the products we get from the processes we go through, some of the challenges and benefits, and then Tony will talk about maximising what you get from it in the long run. And it's not moving.
Okay.
Okay, so we've already heard a bit about AusRAP and what it's about. The UN has adopted the iRAP process, and 100 of their member states have adopted it to basically try and get star rate roads up to a 3-star or better that carry 75% or more traffic. That's going to require something like 15 to 20 million kilometres to be done, to be assessed by 2030. Over the last 10 years, they've done about 3 million kilometres all up globally. So it's a long bit to go through. For this to have meaning, so it can be used on a global basis from a UN point of view, etc., it has to be reasonably consistent. So what works in Australia has to somehow be made to work in other places and vice versa. And I have to say Australia is leading the development of AiRAP and this process worldwide at this point in time. Okay, we'll just see how we go with this thing. So the current AiRAP process, and this is sort of looking at it in a comparison to AiRAP in that space. Manual coding using videos of 50 to 60 attributes, about 3,000 decisions per kilometre to be made when you're trying to do that coding. And that's a real challenge because you're not just saying, is it a tree? You're saying, is that tree closer than that pole, closer than that thing, closer than this? And so when you're trying to do it visually and not having some sort of spatial database to pull it back to, it becomes a real issue. Human brains, or my brain and probably many others, are good for about 8,000 decisions a day. So when you're manually coding, you're pretty burnt out by about 3 or 4 kilometres. But we need to do a lot more than that. So scalability is a problem. When you're doing things from video, you're basically guessing. You're estimating, I won't say guessing, but you're estimating what distance is, what gradient is, curvature, a whole range of other bits and pieces in that space. So there's an error in there. When you're looking at things like curvature, if you have a 399 metre radius on your curvature, you get a very different result if you have a 401 metre radius. And so one of the things that this AiRAP process will allow us to do is, rather than having these bins to go through, gradate it over. And so it doesn't matter whether you're 391 or what. You know, at 399 metre radius, 100 mil difference in where you mark the centre line makes a difference between what's there. So it's pretty difficult. So that sort of false step is a problem. The AiRAP coding rules are complex. When you look at them in their individual right, they're fine. But when you start applying them across a whole heap of different things and taking them into account, it gets really difficult. And people's interpretation of that varies dramatically, which means the results vary quite a bit. The accreditation is of the individual. So you might have a team working for you, but at some point in time, someone's got to sign off on all that. And because it's all manual, they're either got some good processes in place, which are really difficult, or it doesn't happen as well as it should. The output's a single spreadsheet. You've got a lot of information going into that, a lot of work, but you don't get all that. You just get some values. It's useful, but there's a lot more that's not being used in that space. Auditing of it when it's done effectively, to do that properly, the person's really got to go back and redo the whole bit or 10% of it themselves. That's a challenge in its own right. So the end result is we get significant variability in coding decisions, consistency and accuracy of the star ratings, and really limited scalability. And that's going to be a real challenge in meeting UN and IRAP's goals to go forward. The AiRAP process that we'll show you a little bit about uses remote sensing data, and that allows us an accelerating intelligence. When they talk about AI or accelerated intelligence, there is artificial intelligence, but there's also other processes that we use to speed that whole process up going forward. So we're calling it accelerated intelligence. The process and the data are the things that are accredited by AiRAP, not the person. And that's a really important distinction, so you can get a lot more consistency about when you run through. There is this transition that's got to happen from video and manual assessment through to a more automated process to go through it, and the consistency of those results. And so that's another transition that's going on at the moment. We've built a tool, which Tony will show you, that allows us to go from manual right through to automated. That's our road viewer portal we can show. And we see it as being, an important transition in that step. From an AiRAP point of view, the scalability and repeatability, once you've built all those codes up and things, you can do it on a consistent basis. It takes time. And the consistency and accuracy is quite high in that space as well. Auditing is a lot simpler. We can actually generate shape files and show where the key features that were picked up are, et cetera, going through there. And so from an auditor, rather than having to go into an Excel spreadsheet and go back and revisit and do all that, you can just scan over that data pretty quickly. And using some of the tools we've developed, you can actually view it and pan along in that space. There is a step that we've been working very closely with AiRAP on, and that is the development of this dictionary. When you read the coding manual, there is a whole heap of room for judgment in there. When you're trying to do that from spatial data, that room's not there anymore, okay? It's either this or it's that. You don't have these sort of buffer things. And so we've done a lot of work with AiRAP to build up those definitions. We've gone to where we've got a good workable set of definitions, but they'll continue to evolve. And that evolvement will actually be to speed up how the processing is done, rather than, and without really impacting on the ratings and things going forward. To work. So from this, we generate a wealth of information that can actually be used for a whole range of different purposes, and we'll take you through some of those going forward, rather than just a spreadsheet at the end. The process we use, basically we get data from aerial LiDAR, mobile LiDAR, imagery, satellite imagery, OpenStreetMap, basically wherever we can get it from. We then relate that data to the 100-metre segments that are on the road, or a 100-metre segment running through, and I'll talk a little bit about that. We then QA that data, because there's no point putting data into an automated process when it's got gaps, holes and things in it. So we've got to find all those because it just crashes. So we've developed some good tools for that. And from that, we can output 2D and 3D data and QA the whole thing. We then generate effectively what we call our iRAP calculator data, which then gets fed into VIDA and goes up in a spreadsheet. But at the same time, we pull out a whole heap of asset information. How many poles are there? Where are they? What's the length of street safety barriers, et cetera, going through. And all of that we can view in a 3D portal, which helps us in that space. So quickly, just with some of the data sources, aerial data allows us to look up really the context of the road and characterize the road. We can pick out where the various land uses are, area type, but we can also pick out where there's major intersections and where the road might change significantly and all those sorts of things, where there's pedestrian crossings and school zones, etc. So it's a good overall sanity check for us in the first place. Prevalence of aerial LiDAR, particularly across urban areas, which are the hardest area to sort of code, is becoming more and more, and we've started doing a fair bit of work with aerial LiDAR. What you're looking at here is the treatment of aerial LiDAR, which we look at the rate of change of slope. So it's an abstract surface, but it tells us where things change really quickly. And from that, we can start to pick up the breadth or the width of roundabouts, where channelization is, a whole range of bits and pieces really interested from that. And we can automate the processes for extracting that from it. It's just getting access to that data is the challenge. And that's happening. Typically what you've also seen, and hopefully this is going to go, this should go. Yep, is just a video. And this is just the cities. The difference here is we know when it was captured, we know what image you're looking at, we know what road segment in terms of your 100-metre segments are there. So when you actually want to come back and check this stuff, you can really quickly check it. And I won't show it here, but you can pan through that video and stop really quickly. So I could do a 20-metre section of road in probably 5 or 6 minutes by just panning through that space. Okay. We also use off-the-shelf mobile LiDAR. So this is some data from TomTom. We did a project for the European Commission where we looked at the readability of roads for connecting autonomous vehicles. And that's where this came from. But you can see the level and detail that we're getting there. It's pretty good. Survey grade mobile LiDAR, which is similar to stuff that was just been captured from Okaparinga going forward. There you can actually measure a whole heap of things and see everything you need to know and basically do some pretty good detail from that space. We talked about our QA tool. This is what you're looking at is near real-time processing of coloured point cloud data. So basically we take the data that comes out of the scanner, we then process it on the right-hand side. From that, we can pull out where there's road features such as raised medians and other bits and pieces, and then pull out line markings and other bits, all that sort of stuff. The process just before that removes ghost cars and all those sorts of things. That's running on a single computer at about 400 kilometres an hour. So getting quick. But again, when you're doing 20,000 kilometres of data and you want to process it, you've got to be able to run through it that quick to make sure there's no big gaps and bits and pieces in it. Okay. Extraction of features from mobile LiDAR and imagery. We've worked with Imagery and LiDAR together in terms of our extraction process. Top corner is showing you the video that you normally would have had to work from. Down the bottom is our interpretation or what we can extract from that data on the right-hand side. Beauty of using LiDAR is where it's shady, you don't have to worry about it. You can still pick up all the images and features. Where there's, a bit iffy about definition, we can do it. We can jump into that 3D point cloud at the bottom and exactly measure where everything is going forward. And for time, I'll just keep moving on with this. All right. On the left-hand side, we have our normal video. And what I'll show you now is what we're working on, and it's starting to come through. So this is where we fuse the mobile LiDAR and the 360-degree imagery to create a new point cloud. That point cloud is out to the width of the road corridor. Mobile LiDAR doesn't necessarily get there because of all sorts of bits, and you've got gaps and stuff in it. from this, we can actually go in now and have all the benefits of mobile LiDAR and all the benefits of the imagery that are there and pull out all the information we need from that process going through. Imagine having Street View like that, where you can just jump into it and basically measure the height of any pole or anything you want, and that is a utility going forward. That's where we're heading with this. We can take all of that data and drop it down into just a straight little shapefile like that. So we did a project for Main Roads WA, 2,000 kilometres, and pulled out all the certain assets along their road, dropped them at about 2 megabytes of data, which covered the whole of their road. So we took in 2.5 terabytes, gave them back 2 megabytes. And that's what they wanted in that space. Okay, how am I going for time? What do we do? Yep. Okay, so the iRAP challenges, the road segment matching bit, and I'll show you some examples of that. Make sure we get that right because it's a starting point. That's what everyone references back to, etc. This data definitions thing that we talked about, the quality judgments that humans make, which in iRAP coding go really unchallenged, they're just there, but in a digital space, we've got to be able to define them. So how do you define the quality of an intersection, curve, etc.? So it's breaking out all those little attributes and then be able to pick them up and sort of run through them. So curves, pedestrian crossings, delineation, etc. Differences between various states and various jurisdictions in signs and how you mark school zones and all those things, because we're training AI to pick all these things up. But this one's slightly different to that one, slightly different to that one. So we've got to have a process there where we can retrain that AI really quickly when we step into a different environment. And then this data dictionary, the iRAP relies very heavily on the expertise of the person coding it in the first place. Okay, and that expertise is, even amongst experts, is not consistent, as we know quite well. But there's a lot of subjectivity that goes into it. For us to do this from remote sensing in an automated way, we basically have to have good hard definitions. And we've spent a lot of time working with iRAP on that, and we've got to a stage now we've got most of that handled up pretty neatly. And then there's interpretation of coding rules, and I'll talk a bit about that. And then on top of that, there's a myriad of cases because everyone's different and you can train as much as you like, but you've got to, it just comes back to this thing, you've got to have a fast mechanism of retraining your algorithms to go through that. Okay, this is this matching segments bit. iRAP has a rule that says you do, no, sorry, it has a, yeah, I'll call it a rule, says that road segments shouldn't be any more than 20% variation in length. But typically when most of the AusRAP coding's been done before, for good reasons, such as there's an intersection there or two roads joined or whatever, we'll end up with segments that are 45 metres long or 120 metres long, et cetera, et cetera. And so it's really important up front that we flag what's being worked to in terms of the referencing and going back to, make an informed decision. We can set up and make that work, but we need to make sure that that's what you want in that space. Because we came and coded in 100 metre segments on top of that, it'll mean nothing to you. You wouldn't be able to translate the data. Things like, what is an intersection? So this is a really interesting challenge from a iRAP, depending on who you talk to in that space, would either code that as 2 3-leg intersections or as 1 4-leg. And 1 4-leg, if this is close enough in the view of the person looking at it, then the interference on the car, along the road, etc., is the equivalent of a 4-leg intersection. I'll call it 4-leg. But again, from a remote sensing point, from the sort of automated analysis point of view, we need to be able to work out what works and what doesn't in that space. Okay. Similarly, where does the intersection start and where does the intersection stop? And this is another interface. So here we have a roundabout, which is pretty clear as to where the roundabout is from an intersection point of view. From an asset management point of view, you would consider the roundabout. But actually from a coding point of view and an AiRAP coding point of view, because iRAP really runs on 2 levels. It runs on this 100-metre level, all right, for segments, but it also considers elements of 400 metres long or longer for lanes and other bits and pieces. And so when you're deciding whether something is a single carriageway or a dual carriageway, it has to be more than 400 metres long. But then how do you actually work through that? So and then there's rules about how you apply that. So when you're coming into an intersection, because the intersection's got its own risk values and stuff in it, you don't necessarily worry about changes in whether there's a rumble strip and all those other bits and pieces. And so what that effectively means is to do this properly, we have to consider probably, particularly with a roundabout like this one, we're really considering 300-metre segments as being the intersection. And we have to be able to delineate that in the first place so that we get the right results and go on from that point. So one more challenge. We've worked out ways to do that as well, but that's all right. And then this thing about divided versus undivided carriageways. We did a 200-kilometre pilot for Vic Roads last year, and they put a whole heap of wire rope safety barriers along the middle of their roads to actually break it into bits and pieces going through. Those safety barriers, breaks and safety barriers ranged in length from 30 metres for property access to 400 metres. Where does the dual carriageway stop? Where does it start? Where is the right-hand right object severity that you need to code for, stop, start, and all the rest of it? And so there's a whole thing around all that, which again, we've now got to where we need to characterise the road in terms of what's a carriageway, work out where those things are, and then apply our rules underneath that. Just one more challenge. All right, very quickly, benefits. So we use automated, accelerated, and intelligent methods to extract the features from it, which improves efficiency, speed, scalability, and cost. The process and the data is the thing that's accredited by iRAP, not the person. And so once you get the process up, hundreds of people can apply and go through. Higher accuracy, higher consistency of what's been extracted and gone through because it's been accredited and it's in that space, and we're already at that point. Auditing efficiencies improve enormously because we can generate 2D shape files and basically points and bits and pieces and visual information to help you work through that. The data, once you've captured all that, because you know where everything is down to sort of very accurate locations and things, can be used for a whole myriad of things after that, including doing safer road investment plans without having to go back and resurvey the whole thing from that point. And then there's a whole breadth of applications. And I'm going to hand over to Tony to talk a bit more about these, but the range of information that you can actually generate from this data once you've got it is quite enormous.
Thank you, Peter. So you can sort of see there the work that Peter and the team have done to get us to the point where we're now the only company in the world who have an AiRAP accredited inspection system. And I guess the amazing sort of change, I guess, in you having objectivity in accuracy and in just sort of sheer usability and consistency, I guess, globally that we'll be able to realize from that. So as you can see on the table here, there's a whole range of different things. So you've captured the data, you've paid your investment to get the data, you've got all this sort of information to play with. How can you actually get the most sort of return on investment from that? So I'm just going to show you some of the cool sort of products and toys, I guess, that you could extract from that. So as you can see on the screen here, we've got this is automated feature extraction. So no manual import at all. This is what we do as a starting point when we get our mobile LiDAR and imagery in. And you can see the kind of assets that we're extracting from this sort of information. And from that, we can create assets. So, for example, we can tell you in your council area, or in your area of concern, in your state, where every single street light is, or your lane markings, your curbs, where the trees along the road corridor are. Pick an asset, we'll find it for you, we'll tell you where they are, referenced down to, within sort of centimeters. So if you currently have a GIS system where you have items and you're not really sure where they are, or it's not accurate, this sort of process, just as a sort of result of doing an AiRAP rating, you're also going to be able to find out where every single item along the road corridor is. Environmental assessment is an interesting one. So, Anditi started out, we do a lot of environmental assessment work from aerial LiDAR and imagery, but we are now applying that to mobile as well. So here's an example just taken from, I think this might be actually Onkaparinga. So we've just done we've captured data through our partner Veris for an area of Onkaparinga that's, I guess, a bit of a black spot that Brett asked us to look into. And we're about to soon we'll be starting the process of doing the AI rating. So I think this might be a bit of imagery from Onkaparinga. But with our road viewer software, you've got the ability to look in 360-degree imagery. You've got things such as classified point clouds, you've got colored point clouds, and you can sort of switch between all of them. And what that leads us to do is things like here, where we've got a project for Blacktown Council in Sydney, where we had sort of two problems. One, they want to do an AiRAP star rating to find out the safety of selected areas of their road. But two, they also want to plant as many trees as possible to reduce what they have an urban heat bank exposure, I guess, where it's Western Sydney, it's very hot in summer. But the more trees you plant, the worse it's going to be on your star rating. So what we're doing at the moment is these sort of trees we've got here, we've modeled them. Their arborist has told us the species of trees that they're interested in planting. So we've looked at the road corridor, identified spaces on the road corridor that can plant more trees. We've modeled them in based on this is a 10-year maturity that we've modeled out. And then we're looking at the impact before and after of what that has had on the star rating. So they need to plant trees. They've got to improve vegetation and livability. They're also tracking the temperature of the road surface as well. And so we can tell them at 3 o'clock in the afternoon on a summer's day what sort of shading they're going to have on their road for these fake model trees that we've created, and then they'll be able to sort of see what impact that has had on things like I said, livability, temperature, etc. And we can tell them what that impact that will have on star rating. So we could potentially, for the example here, say if you put a safety barrier in, you've got a 3rd star rating of the current, the with trees, and then with trees with treatment as well. So we can sort of model all those sort of things for the people going forward, so they can make sort of decisions based on the information that we're providing, again, rather than sort of getting a spreadsheet and then having to sort of start again. So RoadViewer is AiRAP accredited. So RoadViewer is basically the way of viewing all of our sort of mobile related data. So here's a sort of video play an example. So starting off in 2D, you've got the blue AusRAP segments here. Clicking inside that, you can see we've got outlined in red. We've got a 100-meter sort of segment of a colored point cloud. On the right, we've got all the different attributes. So we automatically create most of those attributes using processes Peter talked about before. But you've also got the ability as traffic engineers, as road engineers, or whatever position you're in, to be able to sort of make edits to these and to adjust. As you saw before with Matthew showing the Vita demonstrator, you can apply those sort of same techniques within RoadViewer. But you have the ability like measurement. So if you're doing a current sort of traditional method, you're looking at a picture and you have to guess things such as gradient of the road or curvature of the road or distance from the side of the road to a tree or the width of that tree or how many trees there might be. It's very difficult, whereas using LiDAR, and this software, we can tell you down to sort of centimeter kind of levels, how far it is from the lane width in this example, the height of the power line to the road. And then you can easily switch between any of them at any point. So you can identify, once you've done a star rating, you can say, here's a segment of road that's 1 star. I can go into that segment. I can look at it in imagery. I can switch between point cloud. When it's classified, you can turn things on and off. So you can filter out the areas you don't want to look at. And then you can sort of make decisions based on all this data. And this is all from, it's a web portal. There's no downloads. It's accessible. Usually I run it on 4G. I'm giving demonstrations to people on 4G out in areas with 10 megabyte download speed, and it still works. So you don't need a degree in RoadViewer to learn how to use it. It's designed for sort of anybody, anywhere to use it, as long as you have internet. Another really important product that we've got is looking at, say, vertical clearances. So here, for example, looking at this bridge, we can tell you by lane the exact lowest point of each of those lanes underneath the bridge. And you can apply that, of course, to tunnels or to power lines, to trees, to any sort of vertical obstacle, of course. And then looking in RoadViewer software, you can do a clipping, take out transects, look at things like slope or whatever you sort of want to measure. And there's lots of different kinds of measurements of things you can do. And anyone online or watching here, if you'd like more information about RoadViewer or a demo, just get in touch with me and I can sort of give you access to be able to do all this kind of stuff yourself. One sort of cool thing we really like at the moment is swept path analysis. So oversized vehicles. So got this demo here of just a standard size sort of truck going around a corner in this suburban road. And you'll be able to see in a sec when it goes through what happens when a truck goes through this street with all these low-hanging trees, and the red dots are going to signify the clashes. So again, like going through underneath these trees, it's bumping that. So you can imagine this is also a very simple kind of one. It's just one little truck and one sort of normal suburban street. It could be a delivery truck. It's not a big deal. We're doing a project at the moment for a multinational wind turbine company. They've got 90-meter wind turbine blades that they need to move. And so for them, the current process is they use Google Street View and Google Imagery to sort of guess, and they'll look at the road and think that looks all right. We can probably fit a 90-meter wind turbine blade down along there. And obviously, if you make a mistake with something that expensive, it's going to be very bad news. So we can plan all that for them in advance. And here's an example of sort of what we've done for them. So on the left, we've done a model. If you can see the blue on the blue line signifies obviously a 86-meter, in this case, wind turbine blade. If this wind turbine trailer and truck tries to go around this corner, what's going to happen? So the blue signifies what they call a low cost. Green's low cost, blue's medium, and red's if you're running into a building or a tree or Montague Street Bridge or something. And on the right sort of signifies again in 3D. So we can supply that information in shapefiles, in these kind of formats, in Imagery, for example. So if you're planning out ahead, we might say, so the example I'm talking about with the European wind turbine company, 200 kilometers of road in Europe, and we could say to them, for example, there are 5 points where you have a problem. There are 195 kilometers might be totally fine, but there are 5 corners or 5 roundabouts or 5 bridges where we need to figure out how are we going to proactively address this before you drive this multi-million-dollar bit of kit down this road and hit that corner. And then here's another image of beautiful Onkaparinga. This is captured by our partners Veris, so you can sort of see like the kind of quality of data that we're getting nowadays. Super high quality from a survey grade company in Australia, and so again with in our portal, you have the ability to sort of share it amongst the whole departments. You can share information, you can make clippings and save data and make measurements and all that sort of thing. So this, I guess, just an example of the kinds of ways that, again, is you can do a star rating. It doesn't have to be limited to that. You have once you've captured that data, you've got access to all these other features, which can then allow you to be more proactive about how you then respond to that star rating. And it's really important, I think, like amongst government departments or council or businesses to share that information. You might have an asset management team, a heavy vehicle team, an infrastructure, engineers, road safety, etc. Working together to basically say, well, let's all chip in a bit of this money and all benefit from the ability to do this. So that is Anditi. Any questions?
That last image was a 3D point cloud, just in case you know.
Yeah, I should say this. That's not a photo. That's
that image is a 3D point cloud
Yeah.
color. So you can go and measure the height of the tree, the branches, the number of branches.
So the pilot we're doing for Brett, it's 32 kilometers of Onkaparinga road, and it's 1.3 billion points along that stretch of road. So you can see that it's about 1,500 points per square meter. So you sort of see the sort of the quality, I guess, of that 3D point cloud you're getting.
About 7 minutes for questions. If anyone has anything, I don't have any on themes yet.
No problem. Oh, gosh. Go ahead. There was a post just a few days ago, either this week or last week, from the iMove CRC that mentioned this technology. So I was just wondering if you could elaborate what your connection with iMove is.
Yeah. Okay. We did a project last year. We sort of finished the report about April or so last year with iRAP, Transport for New South Wales, iMove, and the University of Technology in Sydney, and TomTom. We used TomTom data for all that going through. And basically it was looking at what techniques were available and what data was available to try and do this sort of stuff. And so part of it was looking at TomTom's what they call multi-net data, which is their probe information that goes through. And that covered the whole state. We could pull 6 or 7 attributes out from that going through it. And then another part was actually looking at, and this is the work we did, what you could do with mobile LiDAR and 360-degree imagery. And we did 2 test cases within that, a section in southwestern Sydney, which is about 11 kilometres, and coded all of that and ran through one of the videos. It actually wasn't in that, but yeah, we've got a video to show that. And then we also used a road out of Western Australia, sort of a rural road, to actually show the difference in basically those two. And that's where all that came from. And all the learnings from that were written up in that iMove report, which is a fairly good detailed report, basically telling you about what can and can't happen.
The Western Sydney component was actually what we used as our submission to iRAP to become AiRAP accredited, to demonstrate that this is moving into the new modern version of doing a star rating by implementing this kind of data and techniques.
Just got a question about if a council like Onkaparinga or a private company wants to engage in your services, what does that look like in terms of this plus the data, the LiDAR services to install in the car and contract it out?
So we don't collect any data ourselves. We have a range of partners, aerial partners, mobile partners all around Australia and globally. And so what we would do is, I guess, understand the location. So, for example, for Onkaparinga, we use Veris because obviously for cost, the data capture, the economies of scale play a really important part. And so because it was a pilot project we're doing, Veris had a vehicle going to Adelaide anyway. So we just said to them, can you just spend an afternoon, divert it and pick this up for us? So for someone like TomTom, because they capture millions of kilometers a year globally, they've got a lot of data on the shelf, so we can sort of just buy what we need from, as long as those roads are covered. For custom jobs of like suburban roads, etc., it's better to get, and also, or if you want sort of survey grade quality, we can find the right partner. So what we do is, say for example, I would talk to the person and say, well, what are you looking for, and what kind of things do you want to solve? If you just want to do a star rating, you don't need as high quality data as if you want to do some of the other things I've shown. So once we sort of identified that, then we can figure out the best way of providing the data, whether it's already off the shelf or we're custom capture, and then if custom capture, who's the best supplier that could be able to do that for you, and then sort of get to a point. So we would subcontract the capturing the data. I mean, some organizations, of course, have their own data, which we would then use. So we use lots of different sort of styles from different bits of hardware, provided in different formats. So we've always been a data agnostic company where we take it in from a variety of sources and can provide it in a variety of formats. So we just sit in the middle and work with whatever sort of partner is required in order to get the solution for the customer.
And the analysis itself, is that what Anditi does in the AiRAP? Okay.
Yeah.
We make sure the data is fit for purpose in the first place, because not all data is data, as we've all learned the hard way. All right, so we'll run through our QA processes and make sure that it's good enough, and then what you're getting, because trying to analyze 1.3 billion points and say they're all good is a trick in its own way. So we work through that, and then we just run the rest through our processes to pull out the information in there.
In some ways, we're sort of like those sort of, what are those people called, where they, when you buy like the TV shows where you open up like sort of the storage facility and you sort of see, you dig around what's in there and what can we make out of this, and then we sort of, we can create a range of different sort of things. So but yeah, the whole point, I guess, what we were trying to do is we try and just give as much benefit as possible to say that there are lots of different things that you can do, so that once because capture costs are probably going to be about half of what the cost will be for a star rating in an AiRAP format. So then, like, make sure you use it again as many times as possible.
There's two comments with that. Mobile LiDAR capture costs 3 years ago were somewhere between $350 and $1,000 a kilometre, depending on how you're capturing. Through the work we've done with most of the Australian suppliers, we've got that down to be pretty much what it is in the States now, which is about $50 to $60 a kilometre. And that's made a huge difference in accessibility. They've gone from
A lot of caveats on that. So
yeah,
let's not quote that number.
I wouldn't recall that.
Yeah.
I'll just jump in. We've got about 2 minutes left. We've got one question from team. So it says, how are you dealing with two key inputs to the star rating, which are flow/traffic volume and operating speed, if you want a different value?
There's probably a couple of answers. So often the government, especially if it's government body, they'll usually provide that information themselves. But we have partners that we use. So there's two other AiRAP accredited companies in the world. One's TomTom for providing things like flow data. Another one's a company in the UK called Agilicis, and they capture using satellite imagery. They're AiRAP accredited to capture like flow data. So we partner with them. So it works out really well but together, like the two of us sort of supplement each other's gaps, because we provide information on a static environment and they provide information on the dynamic environment. So we work with Agilicis to provide that information where necessary, but and sometimes it's provided by the end user.
Okay, great. Well, we better wrap things up. So can everyone round of applause for all the presenters today? Thank you. So just also note that we do have another session coming up for the SA chapter in late July, which will be advertised soon. But thank you for everyone for coming and joining us online, and the presenters as well for giving up their time. Thank you.